Hi there. Today we're going to talk about functions, derivatives, and integrals, as well as their applications in real-world situations. So we're going to start with a basic review of algebra and pre-calculus topics. So let's take the function y equals 2x plus 5, for example. Using slope-intercept form, we see that the slope of this function is 2, and its y-intercept is 5. This function can be graphed as a diagonal line. However, finding the slope of a function isn't always as easy. Sometimes in calculus we need to be more creative about how we go about finding the slopes of polynomial functions. This time, let's take the function y equals 2x squared plus 5x plus 8. There are multiple terms, and the slope-intercept form would not be able to yield a proper slope since the slope isn't a constant value. However, the y-intercept would still be accurate. But this is where derivatives become useful. To take the derivative of a function and thus find the slope, we need to take each term of the function and multiply its coefficient by the value of its exponent. Then, from each exponent, we subtract 1 and simplify. Here we multiply 2x squared by 2 and subtract 1 from the exponent, and we end up with 4x. For the 5x term, we multiply 5x by 1 and subtract the exponent of 1 by 1 to get 5x to the 0 power. Anything to the 0 power is 1, so 5 times 1 gives us 5. Then for the term 8, since it can be written as 8x to the 0 power, when you multiply 8 by the exponent of 0, the term goes away. Now the function 4x plus 5 can be used to solve for the slope at any point by plugging in a value for x. But what if you wanted to go backwards back to our original function? Using the same derivative of 4x plus 5, we will use integration. We will take this one term at a time, essentially doing the opposite of what was done with taking the derivative. Let's start with the term 4x. Instead of subtracting from the exponent, we will be adding 1 to it. Then the coefficient of the variable will be divided by this new exponent. So 4x would become 4x squared and divided by 2 to get our original term, which was 2x squared. The same can be done for 5. 5 can be rewritten as 5x to the 0 power. So when you add 1 to the exponent and divide it by the new exponent, altogether you will end up with 2x squared plus 5x. As you will notice, this is extremely close to our original function of 2x squared plus 5x plus 8, but you might be wondering, where did the 8 go? When taking indefinite integrals, we must always add a constant value, or c, to the integral to hold the spot for any potential values that may have been multiplied by 0. In this case, c equals 8. So now let's do some more practice with derivatives and integrals. Say you and your friend are going to a Celtics game at TD Garden that starts at 1 p.m. The doors open at 11 a.m. and you want to find out how many people will enter during this 2-hour period. You are told that the rate at which fans enter TD Garden is modeled by the function y equals 5,850x squared minus 240x cubed, where x is in hours. So using the same procedure as before, we take the integral. We add 1 to each exponent and divide each term by its new exponent. 5,850x squared becomes 1,950x cubed, and 240x cubed becomes 60x to the 4th power. But what about c? Since no one was in the stadium before 11 a.m., c is equal to 0. Now all we have to do is plug in 2 hours for x, and when we solve, we find that approximately 14,640 fans entered the TD Garden during this 2-hour period.